Hello, listeners. As an enhancement to your listening experience, I am now going to present these archive episodes unedited in their entirety, which includes all of my afterthoughts. So, continue listening after the outro music if you want to hear what I thought of the episode. And if you are enjoying the podcast, please support it by going to the homepage, spacerockethistory.com, and clicking on the orange donate button or the Patreon link. And now I can also accept Zelle and Venmo. Just use my email address, spacerockethistory@gmail.com. Thanks.
We choose to go to the moon in this decade and do the other things, not because they are easy, but because they are hard.
Godspeed, John Glenn.
Roger, 0G, and I feel fine.
Getting my feet out. Okay, I'm out.
How does it feel for the United States to be the new record holder?
At last, huh? When that baby lights, there's no doubt about it.
Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
Listen, Tranquility Base here. The Eagle has landed.
That's one small step for man, one giant leap for mankind.
Hello and welcome. This is Michael Annis, and you're listening to episode 272 of the Space Rocket History Podcast. And now, Apollo 13, Free Return, Part 2. Continuing from the previous episode, Jim Lovell was attempting to perform a fine alignment of the two docked spacecraft in preparation for the burn that would put Aquarius and Odyssey on a free return trajectory. When Lovell looked out his window, however, he saw not only the target stars he needed to see to make his alignment, but also thousands of bright, glowing false stars in the debris surrounding the spacecraft. Finding the stars he was looking for was almost impossible. Houston had been worrying about this problem for the last hour, occasionally even calling the ship with the question, "Aquarius, can you see any stars?"
Aquarius, Houston, can you see any stars out the LEM window?
Yeah, we'll have to wipe them off, Jack. They're coated with water right now.
Roger, as soon as you get a chance to, or in your position to take a look, we'd like to know if you can see stars for alignment purposes.
Yep.
Jim, what we want you to do is go with your current final line and disregard the P-51. What we're attempting to do is to crank up some LMS simulations to correlate what we can get out your window with what we can get out the LMS window to see if that'll help us any. So when you can see some stars, if you can, you think you can recognize them and recognize constellations, please let us know.
Okay, we'll check. Stand by. Okay, I'm looking out of Fred's window. I see a lot of particles out there, but a lot of stuff is still drifting away from us. A lot of it is flashing in the local vicinity, and I don't recognize any constellations right now in this particular attitude.
Okay. Okay, Jim, if that status changes, please let us know.
Lovell decided that the only answer was to take control of the lunar module's thrusters and nudge Aquarius and Odyssey around in the debris cloud, looking for a gap that would provide him a clear line of sight out into space. "Hand me a towel, Fredo," Lovell said to Hayes. "I want to see if I can maneuver out of this stuff." Hayes handed Lovell a small square of terry cloth stored in a supply kit to his right, and the commander wiped off his own window first and then his lunar module pilot's window. The two men took a long look out their portholes and whistled in unison. "What a mess," said Hayes. "No worse than over here," Lovell said. He switched the attitude control system to its manual setting and reached for his hand controller. As on the command module, there were 4 clusters of 4 thrusters spaced evenly around the outside of the spacecraft, each of which was placed so that it could exert sufficient torque to rotate Aquarius about its center of gravity. And, as on Odyssey, the entire system was controlled with a pistol grip device. Lovell gently pushed the handle forward, attempting a pitch-down motion. The ship lurched abruptly up to the left. If the thruster system on Odyssey had been difficult, the one on Aquarius seemed out of control. "Whoa," Lovell said, releasing the controller. "That's a heck of a yaw." "That's not the way that's supposed to act," Hayes said. "It's sure not the way it ever acted before," Lovell replied. The problem, as Lovell and Hayes realized, was the combined spacecraft's center of gravity. The LEM's attitude control system was designed to be used only after the ship had separated from the command service module and was drifting along in near lunar space. In the simulators that both Lovell and Hayes had been trained in, the guidance computers were programmed to mimic the mass distribution of the free-floating ship, and the pilots had learned how to maneuver the spacecraft in practically any direction using only the barest puff of propellant to get the job done. The LEM that Lovell was piloting today, however, was not flying free, but laboring along with the cold, dead bulk of a 63,400-pound orbiter protruding from its roof. This shifted the center of gravity dramatically upward, well into the command module or beyond, and the familiar feel of the LEM's perfectly calibrated thrusters changed completely. In the command module, Swigert felt the twin ships suddenly sway around him, and he floated back through the tunnel to see what Lovell was up to. "What's the status down here?" Swigert asked as Lovell gave the controller another gentle push, and the spacecraft responded with another clumsy movement. "Trying to get a star alignment," Hayes explained. "It's not going to be easy with that attached," Swigert said, pointing with his thumb up the tunnel toward Odyssey. "You're telling me," Lovell said, with a frustrated laugh. As Lovell manipulated his controller, the attitude indicators on board the LEM and the angle readouts in Houston began to register the erratic movements of the ships. At the Lunar Module console in Mission Control, Hal Loden, the man who oversaw the navigation systems for the lander, was alarmed when he noticed the motion of his gauges. The indicators for all 3 gimbals in the spacecraft jerked crazily, moving close to gimbal lock. If the gimbals locked and the alignment Lovell had labored so hard to transfer over from Odyssey was lost, any chance of orienting the ships sufficiently for subsequent engine burns would be effectively eliminated. Loden immediately notified Flight Director Glenn Lunny.
On those reports, guidance, you call me.
Roger, middle gimbal angle's getting big, Flight.
Getting close?
It's about 60 degrees.
Capcom, have him watch his gimbal angle.
Okay, I think I hear him doing that. What do you want him to do? Just
well,
roll it
in case he had noticed, it's getting close.
Aquarius, Houston, you're watching your middle gimbal there, aren't you? Go ahead, Aquarius.
Okay, go ahead with the breakers first, Jack.
Okay, you watching your middle gimbal there?
It'll tell me arm. You have to just straight pitch down, Jim. Okay, you're moving away.
Lovell didn't really appreciate the interruption while he was trying to figure out a whole new way to fly his spacecraft. He turned to Hayes and rolled his eyes. Yes, he was watching his gimbals, and his thrusters, and his attitude indicator, and the cloud of junk outside his windows. Lovell said to Hayes, "Tell them that we are." Capcom Lousma, who had himself spent plenty of hours in Apollo simulators, picked up on the remark on the air-to-ground loop and knew enough not to bother the commander again. As Lovell worked to stabilize his ships and Lousma worked to stay out of his hair, Jerry Bostick, Chuck Dietrich, and the other off-console retros, Fidos, and Guidos continued to work on devising a burn that would bring the crew home. The flight plans both the ground crew and the astronauts carried included a number of ready-made abort scenarios, known as block data maneuvers, that contained all the spacecraft coordinates, throttle settings, and other information necessary for a few of the abort situations the crew was likeliest to encounter. There were block data plans for various direct aborts, block data plans for various PC+2 aborts, block data plans for aborts when the ship had left its free return trajectory and needed merely to be nudged back in line. But all of these aborts presumed a healthy command module, a healthy service module, and a limb that would be at best an expendable appendage. Looking over their block data, Bostic and Dietrich did not expect to find a package abort that would fit the current extreme circumstances, and indeed they didn't. Working with their respective back rooms, the controllers were able to cobble together the coordinates for the sometimes considered, but almost never attempted, docked DPS burn, a burn of the limb's descent propulsion system engine with the command service module docked in place. The maneuver would be an almost unprecedented one, but as near as Bostic and Dietrich could tell, it would also be a relatively simple one. From 250,000 miles out in space, a trajectory adjustment designed to aim a spacecraft 40,000 miles closer to the Earth required the slightest tweak of the vehicle's engine. With such a great stretch of interplanetary space to cover before reaching home, a change in orientation of just a fraction of a degree at one end of the journey would compound itself into a change in direction of thousands of miles at the other. Presently, Odyssey and Aquarius were traveling about 3,000 miles per hour, or 4,400 feet per second, and the way Bostic and Dietrich and the others calculated, they would need to accelerate the ships by just 16 feet per second to close the gap from which they would currently miss the Earth, aiming it instead toward a safe ocean splashdown. The controllers were sure the maneuver could be executed, and they, like Kraft, knew it would have to be attempted soon. The later they tried to fire the engine in the ship's earthward transit, the longer they would have to fire it to get the same adjustment in trajectory. But before they could attempt the burn, they would have to get approval from Flight Director Glenn Lunny.
Flight Fighter.
Go ahead.
Bring you up to speed on what I've been doing down here.
Say again?
I'll bring you up to speed on what I've been doing down here. Looking at a maneuver in the present time range, and on the vector that I've got now, I'm looking at about 16 feet per second to get free return.
Yeah, that's what I'm hearing over here in my other ear, Bill.
Alrighty, and I've got the selects down there working on a vector right now. This is on the CSM Doppler after the glitches.
Mm-hmm.
And we're not sure whether it's going to be any better than what we've got now.
Mm-hmm.
So I guess what I've got to say is that in about 10 minutes I can have a maneuver ready. I'll be able to compute a maneuver in time range of 6130. And we can make our decision with that. Delta V will be around, like I said, about 16 or 17 feet per second.
Okay, it's a free return.
That's a firm.
Lunny looked at the elapsed time clock on the front wall of Mission Control. It was now 60 hours and 13 minutes into the flight, about 4 hours and 18 minutes since the accident. Lunny said nothing. Fido Bill Boone waited uneasily, and on the flight director's console, the light for the guidance and navigation officer, which had been glowing a listen-only green, switched to a talk-and-listen amber. Flight guidance, Gary Rennick said.
Flight guidance.
Go ahead.
Okay, we got a good GNN now, and if we probably get a real good burn off now by going ahead and doing it with this good GNN for free return.
Once again, Lunny fell silent on the loop. He did not know all the particulars of this burn yet, but he knew he didn't have to. It was the guidance team's responsibility to calculate the specifics of any maneuver, and if they said they had a burn, they probably did. It was Lunny's job simply to give them the okay to try it. During a mission like this, however, Lunny was not about to give that okay without consultation. Pushing his microphone away from his mouth, he turned toward the aisle behind his seat where, in the last 10 minutes or so, a small group had formed. Joining Krantz and Kraft were Space Center Director Bob Gilruth, Missions Director George Lowe, and Chief Astronaut Deke Slayton. The 5 men were talking among themselves when Lunny turned around, and instantly they stepped closer, forming a tight knot around him and talking intensely. Across the room, flight controllers strained to hear on their headsets, but no word of the conference taking place in the aisle was audible. They craned their necks to look, but the view of the 6 men offered no more information than the silence on the loop did. After several minutes, Lunny signed back on.
Fido flight.
Go flight.
How long will it take you to get a free return maneuver? Could you get one at 61 hours?
Roger that. I can. It's just a question of which vector we want to do it on, flight.
Well, get one at 61 on the best vector you have.
Roger that.
Lunny turned back around. Again, for several more minutes, there was silence on the loop and intense talk behind the console. Finally, the flight director signed back on the communications channel.
Gentlemen, we're going to proceed to do a free return maneuver here at 61 hours. Assume that as soon as we get calm with the crew, we'll see how they feel about doing it there. It's going to be about 16 feet a second, Jack. We want to get on a free return so we can get powered down. And we'll still kick it at PC plus 2 if we can get everything back up in a line properly. But with the way it is, we want to get back on free return. Cost us an hour's time here with the pings powered up. That's 3 pounds of water, and we'll spend that. Okay? Now, Fidos, get me a pad pronto.
Copy.
And run a couple of them in case we get behind on time here. Guidance, what do we need? How do we need to burn this thing? We don't have a vector in there. It's not going to be a guided burn, is it?
Flight, I'm going to have MIT run their hybrid and see if it can take a vector, if it'll work all right.
If it can't, how do we do it?
If it can, we'll do an attitude to hold, P47.
All right. I think that's the way we want to do it anyway.
Yeah, that's the way we ought to work right now, I think. But we're going to look at the other.
Capcom Lousma reached toward his microphone switch to pass this news up to the crew, but before he could, his headset suddenly filled with talk coming down from the ship. For the last several minutes, the attitude readouts on the control officer's console had indicated that Lovell was still working his thrusters, trying to gain control of his spacecraft. Judging by the evidence on the air-to-ground loop, it appeared that the commander had been doing this work entirely in silence, since no communication had been coming from Aquarius during this time. Lousma knew, however, that this was probably not the case. Like the Capcom, the astronauts had an on-off switch attached to their headset cables that they had to press to open a channel to the ground. Although flipping the switch back and forth could be a nuisance, the crew rarely objected. The microphone button provided the astronauts some degree of conversational privacy, a rare commodity in space, and, just as important, allowed them to discuss maneuvers and problems amongst themselves before bringing them to the attention of the ground. The only time this arrangement was changed was during especially complex procedures when the crewmen's hands were full and conversation with the ground had to be constant. In these cases, the astronauts would switch their communication system over to a hot mic or Vox setting, when the sound of their voices alone would activate the microphone, transmitting every word they said directly to Capcom. For most of the flight, the Apollo 13 crew had been using their closed mic setting, but a minute or so ago it seemed they had accidentally switched over to hot mic, and the conversations they were transmitting unknowingly to the ground made it clear that if the controllers hoped to get the ship on a free return route, the astronauts were still going to have to stabilize its attitude. Here's Lovell on Vox trying to get control of his spacecraft.
Now, is there any way I can control this thing, Fredo?
What's that?
Looks like I'm cross-coupling here. I might as well...
Yeah, you are.
Well, I want to get out of this roll. What if I go to, Well, I'm not doing any good here.
Lousma listened in for a few seconds, and, as he said nothing to the crew, Lunny began to listen in too. Like Lousma, the flight director was concerned about what he heard.
Aquarius, Houston, say again, please.
Okay, we didn't answer back there, Jack. Check to see if you're on Vox.
Nope.
Neither am I, okay.
They were on Vox.
Why the hell are we maneuvering at all now? Are we still bending?
Well, we're at hole for one thing. I mean, we're at the minimum impulse.
No, I mean, why can't you null them out somewhere?
Every time I try to, I can't take that doggone roll out. I gotta wait till I get around to the belly band.
Wait a minute. What's the crapping attitude?
We're okay.
Well, we should get to something I know.
Well, as soon as we get over here, we'll stop it with the TTCA.
Okay.
Lunny was concerned as much with the difficulty the crew was having with the ship's attitude as with the language they were using to discuss it. Since the explosion, the TV networks were patching directly into the air-to-ground loop, and every word Houston and the crew said was monitored by the local affiliates. In the past, NASA's air-to-ground feed had been equipped with a 7-second delay to give the agency's public affairs office a chance to edit out any stray obscenity. However, since the Apollo 1 fire, NASA had recognized the importance of maintaining its reputation for unvarnished honesty, and therefore eliminated the on-site censoring. The consequences of the complete honesty were felt immediately. The previous spring, there was a small firestorm in the press when Gene Cernan, piloting the Apollo 10 lunar module with Tom Stafford, let fly an inadvertent SOB after accidentally engaging an abort switch that sent his ship into wild gyrations just 9 miles above the moon's surface. When the Apollo 10 crew returned, the edict was handed down that on all future lunar missions, the pilots were to remember to conduct themselves like gentlemen. Regardless of any in-flight emergencies, colorful language would not be tolerated.
And Aquarius, Houston, we've got you both on Vox.
Like to go what?
You want us on Vox, Jack?
We have you on Vox. We're reading you loud and clear. And
Swaggart, who was responsible for the last explicative, caught the Capcom's meaning. He looked to Lovell and shrugged apologetically. Lovell, recalling his own recent language, looked back to Swaggart and waved his hand dismissively. Hayes, whose side of the instrument panel controlled the spacecraft's communications, reached to his Vox switch and snapped it back to its normal setting.
Okay, Jack, how do you read me a normal voice now?
hearing you 5 square, Fred.
Finally, Capcom got the opportunity to inform the crew on the free return burn plan. During this clip, you will hear the acronym PINGS, which stands for Primary Guidance, Navigation, and Control System.
Okay, we're reading you loud and clear, Jack. I hope it stays this time.
Okay, we'd like to brief you on what our plan is. We're at this time water critical in the LEM, so we'd like to use as little as possible. To do this, we're going to plan to make a free return maneuver of 16 feet per second at 61 hours, which is 37 minutes from now. Then we're going to power down the pings, and then we'll
figure something out.
79 hours, we'll go ahead and make another abort maneuver to kick what we got, but we'd like to get that ping spar down as soon as possible.
After the mid-course.
That'd be after the mid-course. And so how do you feel about making a 16 foot per second burn in 37 minutes?
Well, we'll give it a try, Jack, if that's all we got. That's a 16 foot per second dip burn in 37 minutes.
Roger, we're working up a pad for it, but we'd want to know what you think about doing it at that time.
Well, we'll do it. Can you give us a little bit more time?
Well, we can give him another 15 minutes. Yeah, we can give another... Get a suggestion from him. We can figure it out whenever he wants it. Get a suggested take time from him, Jack, that he's comfortable with. Yeah, it's not going to cost us much water.
Okay, Jim. We'd like to get a suggested time from you. We can figure out a free return maneuver for any time you want to give us. So if you'll give us the time you'd like to shoot for, we'll figure out a pad.
Okay, that sounds good. I think if we have a little bit more time, we want to do it right. Stand by one.
Fido, stand by on a TIG time.
Let's shoot for an hour if we can, Jack. How's that?
61:20. Is that okay? 61:25. Okay.
Okay, Jim, how about 61 hours and 30 minutes? That's an hour and 5 from now.
Okay, we'll do it. We want to be sure we talk back and forth now to make sure we get this burn off right.
That's right.
Affirm.
Salutations from Sheboygan, Wisconsin. This is Michael Annis, your host, and I wanted to say thanks for listening to episode number 272 of the Space Rocket History Podcast entitled Apollo 13 Free Return Part 2. I hope you enjoyed this episode. It was a pleasure to bring it to you. I want to give a big shout out to all my longtime listeners. Thanks for staying subscribed, and extend a warm welcome to my new listeners. I'm glad you're here. If you're looking for old episodes of the podcast, episodes 1 through 91 are available on iTunes, Google Play, and all your favorite podcatchers. Just look for the Space Rocket History Archive. I will try to get up some more episodes this month with the goal of catching up with the main podcast RSS feed. Today, we salute my Patreon donors. Patreon donors give a small amount monthly to support the podcast. Thank you, Patreon donors, who honored your pledge this month. Okay, I had several afterthoughts about this week's episode. I want to credit my sources: Lost Moon by Jim Lovell, A Man on the Moon by Andrew Chaikin, Failure is Not an Option by Gene Kranz, Flight by Chris Kraft, the Apollo 13 Flight Journal, the Johnson Space Center, Glenn Lunny's Apollo 13 Mission Report, the Internet Archive, and Wikipedia. Concerning the colorful language being used by the astronauts, in an attempt to keep the podcast as child-friendly as possible, I edited out some of the harsher swear words. Now, why was NASA so concerned about this? Well, number one, it made the astronauts look unprofessional and as though things were not in control. And number two, with Apollo 10, the press printed and reported stories about the colorful language that the astronauts had used on that mission. And since the press determined public opinion, and public opinion helped determine funding, NASA did not want to give them any more ammunition to fire at them. At the end of the episode, after they finally got the burn plan up to level, you may have heard some long pauses in the conversation. That was Jim talking to his crew. Lovell knew how important the burn was, and he was afraid if they rushed through it, they would make a mistake. So to me, it's very understandable why he was cautious about the burn and delaying it to 61:30 mission time. You may have also noticed the concern over water preservation. As Mr. Lewis wrote in his email last week, the water available in the LEM was the biggest issue for the environmental control system. And more than just having enough water for the crew to drink was having enough water to reject the heat generated in the operation of the lunar module. And that's why they're very concerned about water usage. Okay, I have posted some pictures and the audio for this episode on my homepage, spacerockethistory.com. I hope you check that out. We were pleased to receive several donations to support the podcast over the past week. Jonathan D. from Texas donated above and beyond the Orion level. Thank you so much, Jonathan. Stephen M. donated above and beyond the Orion level. Thank you very much, Stephen. Dirk H. from New Zealand donated at the Soyuz level and earned his moon emoji. Mark S. from Dusseldorf, Germany donated at the Sputnik level. Ryan L. increased his pledge on Patreon to the Orion level with rocket emoji. Bill B. pledged on Patreon at the Mercury level. Ken K. pledged on Patreon at the Mercury level. And Mark U. sent in another donation and moved to the shuttle level with rocket emoji. Over the passing of the months from September to October, our Patreons have dropped to 190. We still have a goal of reaching 218 by the end of the year, and our total donors for 2018 so far have reached 354, with a goal of reaching 418 in 2018. September, believe it or not, and this is unusual, September was the highest month for donations this year. We are very pleased and thankful for that, especially coming off of the dog days of summer. For those of you who are enjoying the content provided here and have not donated in 2018, please consider supporting the podcast if you are financially able. Keep in mind, Space Rocket History is entirely listener-funded. I depend upon your financial support to keep the podcast going. To support the podcast, go to the homepage, spacerockethistory.com. Click on the orange Donate button to make a one-time donation or the Patreon link to make small monthly donations. All donors are rewarded with their name on the donors page at the level they choose to donate. As a special treat today, Mrs. SRH will announce the winner of the weekly giveaway.
Hello, Space Rocket History supporters. This week's giveaway is a Space Rocket History logo magnet. It is 3 inches in diameter, round, and will stick to most refrigerators. To select a winner, I assigned each 2018 donor a number, then put the range in Google's random number generator and got the number for Paul Kinzer. Paul Kinzer, if you would email me and tell me your address, I will mail this out to you. Thank you to all who have contributed thus far in 2018.
Okay, folks, that's all I have for this week. I'll try to get episode 273 out by next Thursday. So long for now.